Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 7th. Looking at significant wave heights for the North Pacific Ocean, we see an area of 20-foot seas, but actually, what is that? Like 15-foot seas south of there, all pushing into California and more expected. This from a gale previously that was tracking through the Gulf of Alaska, producing up to 47-foot seas. That swell hit in Northern California Saturday afternoon, produced some pretty solid long period swell, and is continuing today, though the period's dropping off. Also, a bit of a gale here, trying to organize off of North Japan, but not a whole lot expected from it. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a dip in the jet, sort of like that right there. That helps create a counterclockwise flow in the upper atmosphere and down the surface, and that is the hallmark of low pressure. And low pressure at the surface creates wind, and winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, produces surf. So, what we have is a reasonably well-consolidated jet stream flow. In fact, if this was October, we'd go, hey, this looks great. We have 160 knot winds pushing off Japan. Jet well consolidated. Starts to pull apart a little bit here just east of the dateline, then falls into a bit of a trough, and the jet still consolidated, pushing into Oregon with winds up to about 140 knots. So, a little bit of hope maybe right there. Put this into motion. See that sort of mini trough continues, and it works its way into the Pacific Northwest. And we get a new trough that's forecast building. This is by Tuesday morning here, off of Japan, being fed by decent winds, again in the 150, 160 knot range. And then you get this building split pattern. In between the split flow, typically what you get is high pressure. And high pressure, yeah, maybe if you're on the east coast of the U.S., that's good for producing swell. But mainly, it's wind swell. That's the best that high pressure can do, and normally when it's pretty close to where you are. So keep that in mind. As we get into Wednesday, the trough starts lifting north. Still, there's some expected low pressure being developed from that. The split continues off the U.S. West Coast, northern branch diving in, maybe a little bit of a front there or something. And then you see, look at this, the jet. This is what you call sort of a backdoor trough, because it's the jet, the northern branch of the jet, runs this way up into Canada, and then it sort of ekes out the back way and comes the whole way back in. That would sneak cold air from inland into this area and then back out, and that isn't typically too good. But then you see, look at that, it gets fully cut off, and that trough just dies. What you're going to end up, this is as we get into Thursday night, just a big pocket of high pressure right there. That continues on, but then we kind of suspect the jet is actually split back at the dateline here. It doesn't show it on this image, but that's our suspicion. And that sort of continues into, we're into Monday now. For the most part, most of the energy still reasonably consolidated. I mean, there maybe is some potential here long term. Look at it, there's a bit of a trough there, trying to dig out. Hard to exactly figure out what's going on here with the jet, but we'll say maybe there's some potential. Weak potential. Let's go take a look down the surface, see if that gives us any more clues. Here we are, surface level pressure, surface level winds, all right? We knew there's a trough right around here. What do we get? A 980 millibar low with no real fetch associated with it. That's not any good. We also know there's another some sort of swell, weak swell generation potential here, 984 millibar low with 30 knot winds right there. That doesn't look very good. And then weak high pressure pushing into California, and weak high pressure north of Hawaii driving trade. So let's put this into motion. We're looking for at least this kind of orangish color showing up. There's a little bit as we get into Monday night. Tuesday, 45 knot winds building, lifting, but mainly 30 to 35 knot winds. Building, lifting north. There we go, 45 knot winds on midday Tuesday. Pushing up into the Gulf, still 40 knot winds as we get into Wednesday. Kind of hangs there in the, we'll call this the North Dateline region, because there's the Dateline, this is the North, and it's that little fetch there south of the Aleutians. And, rebuilds to 45 knots as we get into Wednesday night. Even 50 knots. That's almost a storm. Late Wednesday night into Thursday, notice another low building off that. Also notice, though, high pressure, 1040 millibar high. That's bulletproof strong high pressure. North winds raking down the coast. Remember what we said about high pressure generating wind swell? That will generate wind swell, but it won't be pretty. Anyway, and so that gale continues into about Friday, then it fades out while a new gale builds off of Japan. Friday, 45 knot winds lifting north. It sort of hits the same area, North Dateline region, and it fades out. High pressure still in control even into Sunday. We'll get into that in the local wind forecast. And let's see, another system maybe trying to eke out 180 hours out. Hard to say. Looks like at least wind swells still being generated in the western Gulf of Alaska a week out from now. So some potential. All right, let's go see what effect those winds are going to have on the ocean surface. And here we go. Significant wave heights. This is the current frame. We already saw what that does, so let's put this into motion. Both these systems, they all just kind of fade out. Here's the first system on Tuesday, trying to organize, lifting north towards the North Dateline region. Seas, 22 feet or something. Nothing really interesting there until we get into Wednesday night, Thursday, and then we're into, there's peak seas, 34 feet right there. Mainly, we'll say 33 feet, and holding 35 feet. And sort of holding into Friday. So what you could expect is probably some north-angled swell for California, more direct for Oregon, most of the energy targeting right around in this area. Maybe some 16, 17 second period, but not a whole lot of size because the fetch area was very small. Then here comes our next system on Friday, if you believe the models. What is that? 39-foot seas over a very small area, but that'll get you a 18-second period, probably. Small swell at 18-second periods. It, too, makes its track up towards the North Dateline region and then peters out as we get into Sunday, and there we are. So 2 systems for the next week kind of means deadness for a while after the current swell fades out, and then starting maybe late next weekend, something like that, the first of the swells, and then the second gale, if it develops as forecast, could put us swell into the week after that. Let's take a quick look down south. We're going back in time to Tuesday. There we go, Tuesday. Small system developed here in the deep southeast Pacific, but really it's this tiny little guy right there, little low pressure system on Tuesday. It built 28-foot seas, something like that, while this system down here had 44-foot seas. And you would think that this would be the main swell producer, but all this energy was aimed basically due east. Yeah, it'll get up into Chile and Peru, but very little up into California. Where this tiny little system, it was a lot further north. It's, let's see, 10, 20, let's say 30 degrees further north, so that's 1,800 nautical miles further north, and aimed due north. So little small swell is expected from that. There you go. It peaked out with, 32-foot seas over an infinitesimally small area. But small swell should result, somewhere midweek or so, mainly for Southern California, because there's just too much going on north of Point Conception. It would get lost anywhere but except maybe Santa Cruz. And let's see, we'll just roll this out. What happened after that? Not a whole lot. All right, let's go into the forecast for down south. And here we are. We'll just roll through this. We're looking for a system that does not go straight to the east, but sort of pushes up towards the northeast. And our general guess is you're not going to see too much of that. And you want at least a minimum of 30-foot seas. And we're just rolling through. We're into next Saturday, a week out. Nothing there. So a little bit of energy from the south. Now maybe this will lift north. We'll see. But general sense is there's some sort of big high pressure here just pushing everything south. So a little bit of southern hemiswell, probably mainly for Southern California midweek, but that's about it from the southern hemisphere. All right, so current wind situation. Why? Looks like light winds. California, very light winds right now. I mean, it's dead calm in Northern California at 7 o'clock at night, and has been it was south this morning up in Northern California, but the wind pretty much died around, right about as high tide set in, and it's been pretty much butter ever since. All right, rolling it out, you see high pressure just centered right over San Francisco. North winds here for Point Conception, and south winds up north. Northeast trade, east-northeast trades for Hawaii as we get into Monday, turning easterly. And you see building high pressure, and that means the first, and here we go, Monday night, the first hints of the normal springtime pattern driven by high pressure building strong in the Gulf of Alaska. Of course, clockwise flow around high pressure, driving north winds down the California coast. It's good. Builds trades for Hawaii, though. And there you go. As we get into Tuesday, 25-knot north winds, 30 knots in the evening. Wednesday, the wind machine just keeps going. You can see strong trades for Hawaii, 20 knots the whole way. I mean, that's good for wind swell on east-facing shores for Hawaii. You just get this long fetch of, 2,000 nautical miles of fetch aimed at the islands. Only 20-knot winds, but that's enough to produce wind swell. 30-knot local winds as we're into Thursday night along the California coast. Still 20 knots. Friday night. Saturday, maybe things weaken a little bit. 15 knot, 20 knots in pockets. Trade still high for Hawaii, 1032 millibar high, driving all this. And even into Sunday, just doesn't look very good other than just plenty of wind swell. Even if there's long period swell underneath, where are you going to go to get it? You got to find someplace that's protected. And there we are, 180 hours out. Let's go take a quick look at weather for California. So here we are, rain up into the Cape Mendocino area. That's on Sunday night. Monday, it actually kind of works its way down to maybe the Golden Gate or even Monterey Bay. Light rain, scattered showers, maybe a little bit of rain into Tahoe. By Tuesday, colder temperatures drop in. Remember, there's this kind of backdoor trough thing going on. Colder temperatures set in. Snow for Tahoe on Tuesday morning, but it's pretty much out of there by Tuesday evening. There's your 1040. I'll pull this away here. 1040 millibar bulletproof high pressure. That is officially the onset of spring, and that just isn't going to disappear anytime soon. A little bit of rain for Cape Mendocino maybe on Friday, and the high retrogrades and just takes over the entire Gulf of Alaska area. Little bit of rain. Cape Mendocino still getting some rain, but that's about it. So the rain machine stops, the snow machine stops, high pressure builds in, nuking north winds along the California coast, and it's official. Welcome to spring. Quick look at snow forecast for Squaw Valley. A couple inches here as we get into Tuesday or so. And we'll say 9 inches of snow. Snow levels here, so this is the base of Squaw, the dark line, the blue line's the top of Squaw. If it's red, if there's any precipitation, it's rain. So the snow, whatever snow there is going to be only up at the top of the resort. Then colder temperatures come in, but there's no precip. And you just get the sense as we get here later in the 10-day period that it's warm the whole way to the top. This would be the beginning, the first hint maybe of beginning of springtime skiing conditions, which wouldn't be so bad. Corn snow is good. Takes about a week, 10 days of above freezing temperatures even at night, and then you get into what can be quite fun skiing conditions. Quick look at Mammoth. Looks like, 2 inches, maybe 3 inches if you stretch it. And snow levels, almost down to the bottom here. But once you get a week out, it's the same deal. Pretty much above freezing temperatures, not the whole way to the top, but getting pretty close. Of course, Mammoth is much higher with base elevation of 8,000 feet instead of 6,200, and a top of 11,000 versus 8,900. So it's going to take a bit more heat before you have above freezing temperatures the whole way to the top. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation and, of course, El Nino. As usual, we like to look and see what the winds are doing across the equatorial Pacific, and specifically in the western Pacific, in what we call the Kelvin wave generation area, from 170 west over to, this is New Guinea here, this is the equator, date lines right there. So this is the East Pacific. You see east winds. This is from the TAO buoy array. So these are east winds the whole way across the Pacific until you get to about, once you're in the Kelvin wave generation area, it starts at 170 west, 5 degrees north south of the equator. Draw a box in your mind right around in there. You see east winds until you get about midway through the Kelvin wave generation area, and little hints of west winds. That's actual winds, but anomalies, differences from normal for this time of year. You see, those east winds are maybe a little bit stronger than normal, but not much. You see the little tiny easterly arrows. But then when you get into the Kelvin wave generation area, you see actually the winds are westerly compared to normal. That means they're weaker than normal. And so the sense is that if you had warm water here, it would start migrating off to the east. And that is what a Kelvin wave is all about. What's the forecast for the next week? Well, here we go. We'll just slide this guy down here like that so you can see what's going on. Come on, there we go. All right. And so there's the whole plan on one chart. The date line is right there, right in the center. Kelvin wave generation area between those two tick marks. And the Pacific starts, roughly right around there and goes over to about 90, something like that, right around in there. Okay, so reds and orange are westerly anomalies. You can see since the beginning of March, we've had this steady, not strong, but just steady westerly anomalies in the Kelvin wave generation area. But as of today, that's the end of it. By tomorrow, all of a sudden you see, some easterly anomalies, but what you also, it's sort of a mixed bag. We'll call it a neutral pattern. So westerly anomalies are the hallmark of the active phase of the MJO, and of course the active phase of the MJO, especially in winter months, really helps feed the jet stream and promotes storm development. So we've had a run. It hadn't been epic or anything, but there's been steady storms and steady swell production. But this suggests that starting tomorrow and beyond for the next week, there's no real atmospheric support to support storm development other than what is normal. We know that there's 2 small gales forecast, but that sense of continued gale development seems like it might start backing off. So then we got a model that looks 2 weeks out. Now this is not what you think. The oranges are not westerly anomalies. This is outgoing long wave radiation. So that's basically saying the amount of sunlight reflectivity off the ocean surface. And what you see here is there's no blues, no oranges or reds, means just kind of a normal pattern for the out to day 5, out to day 10. Okay. And then at day 15, so about 2 weeks out, you get oranges, which are positive anomalies, which means high pressure, which sort of means not the active phase of the MJO. This would be the active phase of the MJO over here. This is the inactive phase of the MJO. So 2 weeks out per the statistic model. And the dynamic model, the GEFS model, basically saying the same thing. So probably no big change for the next week and a half or so. But then it looks like the inactive phase is going to show up. And that would definitely put a damper on storm development in the North Pacific. All right, let's dig deeper. Phase diagram charts, another way of mapping the strength and the position of the active phase of the MJO. So basically assume you're looking down on the North Pole. And the MJO, active and inactive states, move from west to east from the Indian Ocean over the maritime continent, across the West Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. So you can't see it, but the heavy dots basically there, that's where the active phase of the MJO is. And if it's inside this circle, it's considered to be exceedingly weak. I mean, if we had a dot like up in here in the West Pacific, we go, hey, you're going to get major surf. But down here, it's like the MJO is doing literally nothing to feed the storm track. And the forecast is this little green line right here. No change for the next 2 weeks. The GEFS model, basically saying the exact same thing. We're saying, yeah, maybe the active phase will build in the Indian Ocean weekly 2 weeks out. All right, let's go take a look at the upper level 40-day model. Okay, so this is not MJO, but you can infer it. It's areas favorable for precipitation in the greens, like here and here. You can see it. sort of slides off. This is the active phase of the MJO. Green is favorable for precipitation. Red and orange, not favorable for precipitation. So we'll call this the active phase. They're very weak. Going from the West Pacific, sliding out of the Pacific over Central America. Central America on April 27th. Here's the inactive phase of the MJO, not favorable for precipitation. Dry weather moving into the West Pacific, April 17th. So what's that? About 10 days from now. And it making its way across the Pacific. So that window there, not good for swell production. But then as we get into maybe late April, and that's pretty late in the season, but then another active phase making its way across the Pacific into middle of May. So yeah, and this also holds up for the southern hemisphere too. So if you have the active phase on the equator, maybe, well, it doesn't help the North Pacific any because you're late in the season, but might help kick off a decent storm track in the southern hemisphere, though the correlation in the southern hemisphere is not as strong. And then we get into mid-May, and another inactive phase follows. And yet one more view, the CFS model. This only goes out a month, though, okay? And the deal is, here's the Kelvin wave generation area between these two tick marks going up. Here's current time. And right now, and reds and oranges are westerly anomalies, so we'll say active phase of the MJO, and this heavy dark line here, contour line, that's the active phase of the MJO. So active phase going, that's a week, that's maybe 2 weeks out, active phase, and then it fades out pretty much completely. There's the Kelvin wave generation area, and this dotted line is inactive phase of the MJO, and the blue is easterly anomalies. So for sure, and if you look back in timer, you see it's just been not all winter. There's been westerly anomalies other than this little blip right here in late February, early March. And we've had, not huge storms, but steady swell production. But it kind of smells like once we get into the late April time frame, things are really going to shut down. Let's go take a look at one more model. This is the 3-month CFS model, and who believes a model going out 3 months? But, this is, at a very high level, this model actually does reasonably well. All right, so here's current time. The forecast is going forward. What has happened in the past is down here. Big westerly wind bursts, westerly anomalies here. You can see it in February, the whole month of February. Here's where we are today. This actually, and there's the Kelvin wave generation area between these two tick marks going up. So here's our westerly anomalies. This interestingly shows westerly anomalies. Yeah, you get a little bit of easterly anomalies here for a week or so, and then that fades out, and it's nonstop and building westerly anomalies as we get into May and June. Let's overlay the MJO pattern. Here we go. So here's our active phase of the MJO right here, and that's supposed to hold till, mid to late April, something like that, and then just a very, very weak, incoherent MJO pattern. I mean, look at these: active phase, active phase, active phase, and then just nothing. But westerly anomalies are forecast to hold. That's a good sign. What's driving that? Overlay the low-pass filter here. This is sort of a the solid contour is where on the planet there is a bias towards low pressure, and we see that clearly in effect in the Kelvin wave generation area right over the date line, and forecast to hold the whole way through July. There was some sense, see that building third contour. We thought maybe that was going to be the start of maybe a real El Nino, but you see, there's all that's supposed to happen now. This little tiny dot there, it's all supposed to die out. So basically a continuation of this innocuous, weak, low-pressure bias pattern, sort of feeding the jet stream, but not overly influencing. But you know what? Look at this here, this dotted contour. That would be the equivalent of a high-pressure bias, and that's a sign of La Nina if it were over the Pacific, but instead it's over the Indian Ocean. And even that's supposed to die out. Sense is weak bias towards low pressure as we get the whole way through summer. That would feed the southern hemi jet stream track, and the expectation is we'll have a pretty decent southern hemi swell production pattern this year. Nothing over the top, maybe on a 1 to 10 scale, a 6 or a 6.5. And that's about what we gave the northern hemisphere winter pattern. And it was not that. It was a 5 or a 4, and it was really dead there in the January, February time frame. But, it's way better than La Nina. We'll just say it like that. All right, let's go take a look and see what's going on down in the ocean. So this is the West Pacific here. This is the East Pacific. We're right on the equator. We're going down, like just straight down on the equator across the entire Pacific Ocean to get a sense of the water temperature profile. And this is no different than what it's been. Warm water, 29 degrees Celsius in the West Pacific. Remember, you've got east trades blowing the whole way across, so it takes any warm water that's over here, pushes it off to the west. But 28-degree isotherm line, it was back most of this winter around 160, has pushed off to 132. Yeah, 132 west, which is almost south of California. That suggests warm water is pushing off to the east. And the 24-degree isotherm, of course, pushing into Central America. And here is, now let's look at anomalies, differences from normal for this time of year. And you go, well, I don't see anything too much. What you do see is positive 1 degree, 2 degree, 3 degree over the entirety of the entire equatorial Pacific, and a pocket of 2 to 3 degree anomalies here pushing into Central America. This is a Kelvin wave number 3, generated by, of course, all those westerly anomalies we saw in the previous charts. They've been blowing. They take that warm water here and start pushing it to depth. It creates a bubble, and here's one of those bubbles right there. That's a Kelvin wave. It travels the whole way across the Pacific. Takes about 3 months to do it, then eventually impacts the coast of the Galapagos and Ecuador, rises to the surface, creates a warm water slick there, and that's what's known as a Kelvin wave. Then eventually that warm water gets caught by the easterly trades and starts working its way on the surface across the Pacific on the equator. And if you have enough Kelvin waves and enough warm water, that's how you get El Nino. Here's another view of that same situation. Clearly a strong Kelvin wave here. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5 degrees above normal centigrade temperatures right here. This is Kelvin wave number 3 getting ready to erupt. Here's the last of the upwelling phase of the Kelvin wave cycle, cool water. And this already starting to just barely touch the surface this week. Well, somewhere south of California to about almost the Galapagos Islands. We would expect much more warming coming on the surface in that area in the month ahead. Also, yet more warm water. This was actually connected here most of this week. So another Kelvin wave or a dribble of a Kelvin wave, maybe Kelvin wave number 4 building behind it, maybe just an add-on to Kelvin wave 3. But there's at least 3 to 4 months of warm water. So where are we now? April. So April to May, June, July, August. So right as we start the fall, there should be a reasonable amount of warm water still on the equator off of the Galapagos. And that, in turn, should feed the jet stream and the storm track as we get into fall. Here's upper ocean heat content over the entire Pacific Ocean over time. So back May of last year, you can see warm water tried to make its way over a 3-month period, pushing into Ecuador. That was Kelvin wave number 1. Upwelling phase of the Kelvin wave cycle, a little bit of cool water. Kelvin wave number 2, which started late in September, made it the whole way into Ecuador in the Christmas time frame. Here's our current upwelling phase of the Kelvin wave cycle. That's fading out. Here's Kelvin wave number 3, started in the January-February time frame, mainly big westerly wind bursts. There's your warm temperatures, the strongest of all 3. Still has a little bit to go to make it into the coast here. Still another, what is that, 20 degrees? That's, 1,200 nautical miles before it impacts the coast. So another 3 to 4 weeks, something like that, before it fully starts erupting. But it extends the whole way back to here. So, yeah, a lot of warm water, basically. Months of warm water in the pipe already. All right, surface temperatures. This is sort of the zoomed in South America there, Peru there, Ecuador right there. There's the Galapagos, Colombia there. You see this sort of cool water pattern. We think this is perhaps associated. It could be one of two things. Strong easterly anomalies in this area, which have been happening. Also, the upwelling phase of the Kelvin wave cycle, that little bubble of cool water we saw subsurface, working its way to the surface. But you see here, warm water above normal temperatures. You can see the reds positive. Not hugely warm, but from 20 south to 20 north, filling the entire eastern and central Pacific. And even there's the western Pacific from the date line westward. So temperatures are much warmer than normal. Not super warm, but definitely warmer. And even here south of Mexico, this was cooler last week. It's all filled in as warm. So you could see the effect of multiple Kelvin waves starting to have an effect on the ocean surface. Here's the trend for the past week, and this is actually good news. You see warming here off of Colombia, warming off of Ecuador, warming around the Galapagos. Not super warming. Here's that warming south of Mexico that took place, but just a steady kind of warming trend in this area. That's what you'd want to see if El Nino were developing. This doesn't look like some strong El Nino. It just looks like more of a continuation of what's been going on for almost a year now. And of course, the overview picture, you can see it here. So typical El Nino, you'd see warming in a pattern, sort of like a triangle right here. And we see that, but it's not strong warming. It's, less than a degree, maybe a degree in pockets. So just sort of, and the official El Nino monitoring region, since we're here, 5 degrees north and south of the equator, from 120 west right here out to 170 west. So you can draw a box in your mind's eye right there. We see warming there. Sort of generally looks like El Nino. Kelvin wave generation area from here, 175 degrees north and south, out to about here. So you get westerly anomalies in here. That takes warm water in this area, pushes it to depth. It travels all the way here, erupts on the surface here. The trades carry it off into the El Nino 3.4 monitoring region, which is right there. Nino 1.2 monitoring region, generally just right here along the coast. Let's go look at the absolute temperatures. Here's the Nino 1.2 trend, that area right up there along the Galapagos, Peru. Today's value, minus 0.048, basically dead neutral. But you can see this was that cold water kind of eruption period. It was all right in here, kind of warm, gets cold. There's a lot of noise here, but the trend has generally been downward. But that's not so as important as the Nino 3.4 region, which is right here. And that is, this takes the noise out of it. Today's value, 0.724, where it's been since pretty much nonstop since the end of February. 3/4 of a degree above normal. 5 months of that. Anything 5 months, half a degree or better, and we're just about seeing that. We're officially El Nino, but a very, very weak El Nino. You really need temperatures about 1.5 degrees, maybe 1.2, and going up from there. Then things really manifest themselves well in the atmosphere in terms of storm development. But this is just nothing more than a gentle nudge to support storm development, but nothing more. So what effect have those warm temperatures, if anything, been having on the atmosphere? One measure is the Southern Oscillation Index, right there, SOI, the 30-day and the 90-day, and the daily contribution. Okay? Difference in pressure between Darwin, Australia, and Tahiti. When pressure's lower in Tahiti, the index goes negative. When Tahiti has lower than normal pressure, that is at least a sign of the active phase of the MJO. And if it stays negative long enough, could be a sign of El Nino. Today's contribution, positive 11.53, not so good. But you can kind of look back here. We actually went for 50-some days with it being negative, but starting April 3rd, it went positive, and it doesn't look like that's going to change. 30-day average, it was down to minus 6.99. It's starting to rise today, minus 3.68. That's not a good sign. The 90-day average, if this is down around minus 10, 12, something like that, hey, maybe you have El Nino. Today, we're at minus 5.94, and it's actually lost. It was at minus 7.55. March 31st, and you can kind of look back there and see the trend. There's actually a little handy-dandy graph right here. This line, this is what, March, so 1 month's worth. You can see the 30-day average has been slowly creeping up. The 90-day average creeping down, but not markedly, and recently just heading back up. So no clear sign of El Nino in either one of these indices. So then we go to the ESPI index. Instead of difference in pressure between the area north of Darwin, Australia, and the area, basically the entire equatorial Pacific, it's the amount of precipitation. Theoretically, if you have warmer than normal water here, you get more evaporation, and more evaporation gives you more precipitation. You can kind of see here, this is rainfall anomalies last 30 days. The blues, more rainfall than normal. So, yeah, rainfall in the dateline, but when you get over here to the all-important East Pacific, yeah, below normal, if anything, north of the equator, a little bit above normal. The index, 0.55, it's positive. So, yes, there's a little bit more rainfall in this area, so that would be from here out to here, but it's the position of that. You really want it more in the East Pacific, and it's more focused on the dateline. So, yeah, maybe a little bit of help for the jet stream, but not much. So you sort of get why this winter was nothing great, because this index only recently has been getting positive. We're basically just now have dug past our La Nina, our 2-year La Nina. We're neutral, a little bit more than neutral, but you know, yeah, officially it's El Nino, but it's really not. It's just basically neutral biased a little bit in favor of El Nino. So, and that's exactly the way the atmosphere seems to be reacting. So, to put a bow on things, all right, 2 different gales forecast, mainly for the North Dateline region. They'll create some swell, mainly pushing east, sideband energy into Hawaii. Trades finally take root in Hawaii. Probably pretty strong trades, if anything. The downside to that, relative to California, is springtime high pressure building starting Tuesday. North winds in control for the foreseeable future. So even if there is good swell, you got to find some protected little corner to try to ride it. It will probably push water temperatures down in Northern California. We'll get a big rush of upwelling due to, 5 days of nuking north winds. So that's not so great. Long term, yeah, MJO not doing a whole lot. I mean, once you get into the springtime frame, the MJO doesn't do a whole lot, both in the northern hemisphere and the southern hemisphere. So no clear support. And the active phase, if anything, we're going towards inactive, let's say 2 weeks out. So no clear support for storm development after 2 weeks from now. Longer term, yeah, we're kind of El Nino, but we're really not. Kind of what they call Modoki El Nino. It's just sort of there, but not really. We didn't look at the long-term forecast for water temperatures, but you know what? They're basically the same as they've been all along. Supposedly, the warming peaking in the July timeframe, which is just in sync with the final total unload of Kelvin wave number 3, but that doesn't dissipate until we get into even past Christmas. I mean, we're talking, 9-10 months from now, 9 months from now, sort of thing. So generally, a generally supportive pattern as we get into the fall and the winter of next year for storm development. Nothing over the top, though. And then after that, who knows? But that's it. Take what you can get while you can get it. There are waves. Go surfing, at least tomorrow if you can. Anyway, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.